let's get some data and start doing some stuff. So go to this page. The link is in the assignment, and we're going to go to the data link and download it. To do this, right click on it and save the link as. And then you can name it whatever you want. I'm going to name it 2012. This is census population data, as you can see right here. 2012 national population data sets. So 2012, I'm going to save that, replace it, and then I'm going to open it up. Go full screen. So there's a lot of data here. I'm going to do something a little bit different than what you're going to do, or just to play with the different data sets. So I'm not giving you all the answers. So I'm going to delete all the data that you're going to be playing with. Delete. So by clicking on a row, you can select all of the data and change the size of it or some other sorts of things. So I just deleted all of it. If you'll look, so got a couple of different things up here. Up here are the names of the variables, but they're a little bit squished. So if you click right in the corner, select everything, and then double click on one of these lines of the columns, it will give everything equal space. So you'll be doing this for every single state. I'm going to be doing it for the regions. But this doesn't quite work. We don't know, some of these names we can kind of figure out, but some of them don't make any sense. So sum level, region, division, state, name, that makes sense. Census 2010 population, or POP, that one makes sense. But then we go into NPOP, CHG. Might be able to figure out what some of these things are, but some of them just don't make a whole lot of sense. So first thing when dealing with any sort of data set is to look at, well, once you get it, is to look at the documentation, which is, where did I put Chrome? The file layout folder. It's a PDF file. And so this tells us what exactly all of those things mean. So sum level is a geographic summary level. Whatever. Region, region code, division, census division code, state, the FIPS code. Then we come down here to, so N, pop change 2010, numeric change in residents to total population in 2010. And from 2010 to 2011 and 2011 to 2012. And so you can go through and see what everything means. And here's what the summary levels mean. So if it's 10, that means it's for the nation. If it's 40, it's for the state or statistical equivalent. Region codes, division codes. Those will be useful if you want to do a more advanced version of this assignment. Okay, so now we know kind of what things are. Let's go back over to the data itself. So the first thing that we want to do is we want to create some descriptive statistics. And in Excel, this can be really, really easy. In a spreadsheet, every cell, or the program knows where every cell is, and so you can reference different cells. So if we want to take the average, actually I'm going to delete the United States as well, so I just have the regions. Delete that. Okay, so now I have Northeast, Midwest, South, and West regions. And I want to know what the mean is, the kind of the average population for this data. So if I click on this cell down here and hit the equal sign, this tells Excel that we want to do something. We want to have a formula of what's going on. And we have this wonderful command called average. There it is. Average. Oops. And so it'll come up with some parentheses. And I'm going to click up here and drag down. So I select all of these numbers and hit enter and make sure that they're in the parentheses. If I hit enter, this is the mean. This is the average population from the census from 2010. And this is what's really nice about it. Well, let's go into the formula. So in the formula, we've got average. And if you're curious about what Excel actually means by average or any of the commands, you can click on this link and it will bring up a dialog box that will tell you. But for average, average is the arithmetic mean. So what we've been talking about. So it sums up all of the pieces of the data, these 4 pieces, and then divides by how many there are, so 4, to give us a mean. These numbers, this F2, F colon F5, are the references for what cells in the spreadsheet are being used. So let me get out of there. So this is column F and rows 2, 3, 4, and 5. So F2 through F5. But I don't want just the mean for this one, and I don't want to have to type everything in. So if I grab this little blue box down in the corner, I can drag that over. There, now I have numbers all over the place, and if you look at them, they all do the same thing. They say average, and the only thing that's changing is the column number. So there's H, I, J, K, L, M, all the way down. So I've just created means for every single variable in the data set. So that's helpful. But there are more descriptive statistics that we want. So I want the mean, I want the median, I want the mode, and I also want the total, the sum. It's another one of the questions in the assignment. So total. Now, one trick that we can do, and this is sometimes helpful, sometimes not so helpful, but I'm just going to show it to you here, is, actually, let's go down to here and do median first. So again, I want a formula, so I start with an equal sign, and then, let's see, start typing in median, and it pops up median. Select the same set of data, and there's the median, which is the middle number. So I've got the mean, the average, the arithmetic mean, got the median, and then for this next one, I'm going to do something different. So in the formula, we can, as we already went over, so that's the column name and row number, column and row. If you put a, let's see, a dollar sign in front of the row numbers, it will lock those into place. And I'll show you what I mean in just a minute. So I'm going to hit enter. And just like before, I could drag this sideways and get the median for all these things. And again, you'll notice that it's just changing the column number, GHI. Now you can do the same thing, come over here, going down. You don't have to just do it across, you can go down. But an interesting thing happens. So if I come down like this, so there's my average, J2 through J5, but if I go down, it changes the row number. If I click on it, I can see it. It shifted the entire thing down, which is not what I want, right? So now it's trying to create an average, but it's missing one of the key pieces of the data. So that is not what I want at all. Oops, escape, undo that. When you put this dollar sign in, that kind of locks it in. And so now it's exactly the same, and if I click on it, you can see it's just still doing the same set of numbers, looking at it. And then I can go in here, and instead of doing median, I don't want median, I actually want a mode. There's a command for mode. And then for the total, I don't want median, I want the sum. Just add it all together. Now, you'll notice that the mode did not actually give me a number. Oops. And your job is to figure that out. Why? Why is the mode not giving me a number in this instance? So I'm just going to drag this across a little bit. And so what I have here is the mean, median, mode, and sum of these variables. And mode's giving a weird answer, but we'll do that later. The next thing, one of the other summary statistics you're going to be asked to do, is the range. Now, range, remember, is how many numbers are actually involved in this set. And so the way, there is no range command. I don't think, maybe there is. Range, nope, no range. Okay, I didn't think so. We can never be sure. Sometimes they update programs and you don't know. So the way to do the range is we're going to kind of combine a couple of functions. And if you want to break them out, that's fine too. And do, because we're going to look for the maximum and the minimum and then subtract them to get the range. And so I want the maximum number here. So max F2 through F5. But I don't just want the maximum, I want the range. And so that's the maximum minus the minimum. So subtract then the minimum of these same numbers, 2 through 5. And that gives me the range. If you want to break it out, if it's not quite making sense, we can do it this way as well. So we'll say here's the max, here's the minimum, and just type in the commands individually. So the maximum of these numbers, and then the minimum of these numbers, and then the range. I'm going to do it down here. We'll have another range. Range 2. Range will equal the max minus the minimum, and we get the same answer. So two different ways to get the same answer, the range. And so this is the part of the variation. Anyway, it's a useful concept. So how many numbers are actually involved in here. Oftentimes, the range is really not the most important part. People are more concerned about the maximum and the minimum. So some places you just need to display those, kind of see what is the difference. And that's a pretty big difference. But the range gives you that same difference. It gives you exactly what that difference is. So there's how you can do that. Excuse me. And so those are the first basic steps of how to get some basic summary statistics. And then your job will be to kind of do this the same for all of the states. And then explain them. Why? How does this help? What does this tell you? Is this easier to look at? And there are some other things that we can also do. So I'm actually going to get rid of more of this data. Well, let's see. How much of the data do I want to get rid of? Yeah, I'm going to get rid of most of this. It's good stuff, but not what I want right now. Oops. So I'm going to select all these columns and delete them. So I'm just dealing with the population estimates. Okay, so mean, median, mode. I drag these over, have a nice little table, and we'll pretty that up in just a few minutes. But first I want to do a little bit more. Because what we can look from here, what we can see from here is this is time series data. This is data collected over time. So for each region, we have the population estimate for 2010, 11, and 12, and we can actually figure out how fast these things are growing. And there's two different ways to figure out this growth. So one way is we could look at the total number of people that are added. And the way we can do this is equals, again, formula. So 2012 minus 2010. And we're going to use this one because this is an estimate base, but this is the actual estimate. They're a little bit off, but since we're using an estimate for 2012, just to keep it consistent, we're going to use the estimate for 2010. So, the Northeast region, I'll put a comma there so it's a little bit easier to figure out what's going on. 384,000 people over a 10-year period. And that's due to migration. So people are coming in here, moving here from other places in the United States or from outside of the United States, and then there's also people being born, and then there's people dying. So this is the total number of people who are added. And as we drop this down, our formulas still are good, looking at the right things. So the Northeast and the Midwest, both pretty similar. Only about 40,000 people difference as far as the number of people they added, but then you look down at the South and the West region, and they grew a ton, especially the South region. 2 million people added. Almost twice as many as the West region. So that's really cool to see where kind of the population is growing. You can then hypothesize about, well, why? Why are people going here or there? Is it due to the birth rates? Is it due to people aren't dying as fast? Or are people just moving here because it's maybe a better economy? There's a lot of different questions that you can start to look at, or that may be piqued by this. But that's not all. So this is one way of looking at it. There's just the total number of people who grew. But what if we want to know kind of what the percent growth was? Maybe these people didn't grow, or the Northeast and the Midwest didn't grow very much. Well, let's see. Not because they had too many people, but what is the rate? So, the percent change. Percent change, because if they started out with a low number, that may be really a lot. And so the way you do percent changes is, again, it's a formula. We want the difference between these two, which we can just take it from here, total number added, and we want to divide it by the number that we started with. And drag that down. As a percent, let's see. So really, okay, that doesn't tell that much different of a story, which is too bad. Sometimes it does, sometimes it doesn't. But what this would tell you is kind of how fast they're growing compared to their base population. So in the Northeast, 1% growth, it's not a lot, but it's not outside of a normal range. Because, even the really fast-growing regions are only growing at 2%, which makes me think that they probably have a larger population to begin with. Because when you look at a 2 million person increase, that's a whole lot more than in the Midwest or in the Northeast, but it's not that much more of a percent change. And if you look at the actual numbers, you see that that's right. There are just a whole lot more people in the South. And if there are a whole lot more people in the South, you'd expect there to be more babies born. You'd also expect more people to die. And you might expect more people to be going there. And this is actually a trend we've seen for a really long time. People are moving to warmer areas. You talk about snowbirds. People moving down into Arizona, down to Florida when they retire because it's nice, it's warm, and the weather's nice. And so everyone's moving to these nicer climates, away from the snows that you see in the Northeast and in the Midwest. And so while the total number of added population for the South and West looks huge in comparison, when you look at the starting populations, it's really not that much. It's still double the percent change that was going on. So there's still something that's drawing way more people there. But you started at a different state. And so percent change. So that's kind of interesting. There's some fun numbers there. So now what? Because really all we have is still just a table of numbers that can be kind of hard to look at. And this is where graphs come in and charts. And if you do a chart right, it should be able to tell the entire story for you at almost just a glance. And for this to happen, you need to think about how you want to present your data. What's the best way to actually tell this story? And what is the point that you're trying to get across? And so there's a couple different ways we can do this. And we are going to do, let's start with the percent change. So if we select these cells and then go over to charts, let's do a column chart. And Excel will give you a whole bunch of different options. In general, this is just good design practice. Don't use 3D. Unless you have a really, really good reason to, don't use 3D. And there's a guy by the name of Edward Tufte. And he always talked about the information to ink ratio. How much ink are you using to present the same information? And 3D charts use more. They clutter up the graph, and they make it more complicated than it needs to be. So you want to, in general, you want to aim for simplicity, because you just want the information to show up as easy as possible. And so here we have percent change, and we can see 1, 2, 3, 4. So that doesn't make any sense. If someone just looked at this, you're like, percent change of what? I see that some bars are big and some bars are small, and that really doesn't matter at all. Percent change and percent change. So let's do some things to make it better. So the first thing we want to do is change our axis. So we're going to go to select the data. And we've got the right data here, but we could do better with our names. So let's select our names over here. Wait, is that right? That's not right. There we go, x-axis labels, that's what I wanted. And we'll select these. Say OK. And now we have so that makes a whole lot more sense. So now it's not 1, 2, 3, 4 down here at the bottom. We actually have the names. But percent change, this title still doesn't help at all. So we need to make a more descriptive title. So the percent change in population from 2010 to 2012. So that's better. Now I actually know what it is we're looking at. This is a label of this series. It's this number right here, but that doesn't really do anything. We're already talking about a percent change up here. There's only one thing that we're looking at, so let's delete that. So we have the percent change in the population from 2010 to 2012. We can make this a little bit more descriptive. Oops. By region. There. So now we see Northeast region, Midwest region, South region, and what is the story? Well, the story is that the South and the West region have almost twice as much, or are twice as big as the Northeast and Midwest region. They're growing at a much faster rate, double the rate. And so if that's the story you want to tell, that's great. And there are some other things we could do here. We look at the vertical axis, 3, 2, 2, 1, 1. That doesn't, there's a lot of redundancy there. So again, we can format, if you right-click on anything and you can get to change it. So let's format this axis. let's go to the scale. Let's get that out. And this is saying, so what is our scale? What do we want? So the minimum is 0. And you pretty much always want the minimum to be 0. This is one of the easiest ways to lie with charts and with statistics, is to change the minimum value on the axis. Let's not do that either. Let's see what happens. That didn't do anything. Let's do it again. And when you're making charts, just play with things and change them and see what happens. Let's see. I want our maximum to be 4. Nope. And we'll keep it where it is, 2.5. Maybe what we need to change is our number. But that's linked to the source, so that's probably a good idea. So how do we change our scale? Is it reverse order? Nope. Nope. Logarithmic scale? Nope. Nope. Maybe we can't fix that one. That's irritating. Maybe if we make it bigger. Still doesn't help. Well, there you go. So some things you can change and some things you can't. And this is one of the weaknesses of Excel. So while you can change most things, and by all means continue to play around and see if you can figure out how to change that, it does tell the story. It's a little bit ridiculous to have these multiple values, but it kind of works. So that's how you can make a chart. We could change this chart. If we wanted to, we could turn it into a bar chart. Same data sideways. Turn it into a pie chart. But in general, most graphic designers and data visualization people are saying pie charts are really just a bad idea. And the reason is because of the way the brain processes the information. When you're looking at a bar chart, it's very easy to see the height. It stands out. When you go back to a pie chart, you're not looking at height anymore, but you're actually having to look at the angle and figuring out the distance between the angle. And so this one isn't terrible. It's not a terrible pie chart because we're looking at percentages anyway, so total. Well, I guess that does kind of, it's a bit misleading. But just the mere fact that your brain has to calculate an angle makes your brain work a little bit harder, which is the opposite of what we want to do. So we want columns. Columns or charts or bar charts are usually the most effective way to do this. Anyway, so that's a good chart. Let's change it though. Let's grab our data and see what happens if we do it that way. Well, first, that doesn't make any sense. It's all one thing, and that's because, again, our axis has changed. So let's format the axis. And our maximum is huge. And let's display our units in the thousands. That's still huge. Alright, instead of doing it that way, let's delete that chart and try and make a new one. New column chart, new data. There we go. And again, we need to grab our x-axis labels, which are over here. Okay. Change our chart title. Total population added from 2010 to 2012 by region. And that looks pretty much the same. Get rid of that thing. Actually, let's copy this chart, paste it, and then see if we can move the data over there, and that automatically scaled it. So in both of these charts, we have a 0, start at 0, and we go up. And what is the difference between these two charts? Which one is better? Well, it depends, again, on what story you're telling. So when you're looking at the percent change by region, the South and the West are roughly the same, and the Northeast and the Midwest are pretty much the same. And these South and West regions, these warmer regions of the country, are, it looks like more than double, but really it's about double the growth rate, the growth percentage, than the Northeast and the Midwest. If you look on this one, on the total population, you see you'd have a different story. Again, the Northeast and the Midwest are pretty low, but the South is huge in comparison. And the West is not, the South is almost twice as much as the West, which is still like 4 times as much as the Northeast and the Midwest. So, what's right? Well, they're both right. They both are an accurate representation of the data, and this is why it comes down to the storytelling. What is the story you're trying to tell? Which one tells that better? And that's for you to decide, and for you to be thinking about. So one last thing before we're done with this tutorial, and that is making a pretty table. Because while charts are great and wonderful, sometimes you do have to have tables. And in case you're not clear, a table is a series of numbers. A chart is a picture, like a bar graph. A chart is a graph, or some sort of visual representation of the numbers. A table is the actual numbers. And so what I want to do is I'm going to take just a couple of these and make a chart, or a table out of them. Sorry, even I get confused. I'm going to copy these. I'm going to put them down here. And if I just copy them straight, there'll be a problem because it will copy the formulas themselves. Remember, those are all formulas. But by right-clicking, I can paste special, and I can just grab the values. And then if I look at this, it doesn't give me a formula up here in the formula bar. It gives me the actual numbers. So I want to format these a little bit. Over here, we can change what the numbers are like. We can make them percents. We can add 1,000 separator, get rid of the decimal points because we're dealing with population, and it's very hard to get a fourth of a person. I suppose maybe if you cut off their arms and legs, but anyway, maybe children. Children only count as partial people. So here we have the beginnings of a table. I also want to grab the names of these data, but I want to make them a little bit more clear. So let's go 2010 census population, and we're going to go 2010 census estimate. And summary statistics. Well, let's go descriptive statistics. Okay. So usually when you make a table, you want your table headings, or the column headings, to be a little bit bold. And we formatted the numbers, so that's good. We can also kind of group all of these things together with the use of borders. So let's make a thick border box around all of it. And then to make this stand out a little bit more, give them a double bottom border. That's actually probably okay. And so now as we look at it, we can say, all right, what is the average of the actual census population? So the way the census does things is they guess, they have estimates on how many people are in any given area. And then every 10 years we have the decennial census where they actually go out and count everybody. And they always find their estimates are a little bit off because they are guesses. They're good guesses. And so here we can actually see, it's like, okay, our average census population by region was 77,186. Over here, census estimate, it was only off by, so the first bunch of numbers are exactly the same, 877. Now we could make another column here and say difference. Bold that. Let's put a double thick box around that one, showing that it's a little bit different, and then still get our double bottom border, and we can add a couple of, what is the difference? Oops. Between these things. Oops. And the thing when dragging it is it's going to screw up our borders again. But that's okay, we can just add those back. So grab that thick border box. Okay, so now we have our population, our estimates from the census, and then what the difference is. How close were we? And so pretty close. 493 people is all that we were off as far as the mean, the average, in general by region. The median was only off by 281. And in total, we were only off by about 2,000 people, which is pretty good, pretty impressive. So the census does really, really good work as far as guessing how many people are in here. Anyway, a table like this, then we could drop into a report, we could drop into a Word document and send that off with our charts and our analyses and say, look, here's what's going on by region from 2010 to 2012 from the census. This is what we can understand. And then, so we could either drop these into a Word document if we were going to do a report. For this assignment, what I want you to do, though, is to grab a bunch of cells, a big block. I want you to merge them all together so you have a nice big writing space. And I just want you to write. Explain to me in words. And this is one of the things that personally I find really obnoxious when I'm writing reports, but it's absolutely essential, is whatever you have in a table, whatever you have in a chart, you also need to explain in words. Tell them what's going on. And when you do this, highlight the most interesting part. So here I would probably say something that, when looking at the descriptive statistics of these two variables, these two columns, we find that the census is not, the estimates are very, very close to the actual population that we can find. When we're looking at the charts, just like we already talked about, in chart 1, we'll say this is chart 1, when you're looking at the actual population, you see that the South has like a 5 times higher, 5 times greater amount of total population growth in 2 years than the Northeast and Midwest regions. But when normalizing that for their starting population, when we divide that by what they actually started with and look at the percentage of growth, it's not nearly the same. That the West and the South are fairly comparable as to the number or the percent, the rate at which they're growing. And so all of that information I would be writing down in this big text box. And this is what I want you to send to me. When you save it, this is essential because little information on file types. You downloaded a CSV file. A CSV file is great and a wonderful way to read data across a whole bunch of different platforms, but it cannot hold these objects. It cannot hold your charts. It cannot hold your tables that look fairly pretty, with the exception of these NAs that you need to explain as well. So save this as an Excel spreadsheet, and pretty much every possible spreadsheet application, go to File, go to Save As, and change this format from CSV to Excel Workbook. Save that and send that to me, upload that via Canvas, and that's what I'm looking for. So go through the instructions in the assignment, pretty much do the exact same thing that I've done here. Use these formulas, spend some time, figure out the story that you want to tell, or the story that you find most interesting, and send that to me, and I look forward to seeing all of that. Thanks.